So number 7 is f of x equals 2x to the third plus 7x squared minus 12x plus 4. And now they're asking us to state all the possible rational zeros. Remember, we use our p over q to figure out rational zeros. So this is going to be factors of p are going to be 1, 2, and 4. Factors of q are going to be 1 and 2. So that means that my factors of p over q are going to be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, and then plus or minus 1/2, plus or minus 2 over 2, plus or minus 4 over 2. Now, which ones can I get rid of? Which ones can I get rid of? Brother, what do you think? 4 over 2. Very good. So what I have is I just have the Tetris piece. Okay? So now, we use these numbers to guess while we're synthetically dividing. What is the number that I would like to have as my remainder? What is that ideal number that I would like to have? What do you think? Stephanie?
0.
0. Good. Okay, so we just need a number that we can guess with. So what do you think? Danny, what do you think? 1/2? So 1/2, let's see, 2. 1/2 times 2 is 1. That's an 8. 4. -8. Danny! Good job. Okay, so now, once we've determined that 1/2 works, remember, you have to identify that as an answer. So x equals 1/2. Keep that in there. This 2 used to be x to the third. It is now x squared. This 7 used to be x squared. Now it's 8x, and this -8 stays there. So I've got 2x squared plus 8x minus 8 equals 0. Now I can go ahead and divide everything by 2 to reduce everything. X squared plus 4x minus 4 equals 0. I'm trying to think, are there two numbers that multiply to -4 and add to 4 at the same time? I don't think there are. As tempting as it looks, it's not quite true. So I'm going to go ahead and use completing the square. Which means I'm going to add the box to both sides. I get a 2 here and a 2 here. So I get x plus 2 squared equals, that's a 4. 4 plus 4 is 8. I take the square root of both sides. So I got x plus 2 equals plus or minus 2 root 2. And I'm going to subtract 2 from both sides. So I get x equals -2 plus or minus 2 root 2, and that's it. Okay? Now, please remember that that is in addition to the answer that you already have. So the answer that you already had was that one thing at the top. I think it was a 1/2, something like that. So that needs to go here. All right, so these become your answers. All right? Any questions on that problem before you can't undo? Before I erase it. Any questions on that problem before you erase it? You good, Sayana? Good. Okay. All right, so now, let's see here. Delete. What's next? Number 11? Ah, yes. So it says g of x equals x squared plus 2. Now it's telling you to find g of x. The way to figure out g of x, first of all, I prefer writing it like this, g of x. That way you can have a clear understanding of what's on the inside, what's on the outside. On the inside is g of x, on the outside is g of x. We really have two functions here, so I'm going to go ahead and write g of x again. If I asked you guys to plug g of x into g of x, that would be the same thing as asking you to take this thing and putting it into here. So g of x is going to be parentheses x squared plus 2 plus 2. I'm sorry, squared. So now I got to FOIL this thing out. This is x squared plus 2 times x squared plus 2 plus 2. So now we FOIL this thing out. This is x to the 4th plus 2, 4 x squareds plus 4 plus 2. So you should end up with x to the 4th plus 4x squared plus 6. That is number 11. Who asked for number 11? Okay, good. Yael, does that make sense to you?
Yeah.
Okay. What's next? 21. Let's go to number 21 real quick. Okay, state whether the two functions are inverses. Okay, these problems here are rather evil. Okay, remember, the way to determine if two functions are inverses is if I compose them, if I plug them into each other, and the resulting product is x, or in this case, the resulting product is n. So let's find out what g of f of n is. This is going to be kind of a bear. It's the 5th root of 2 times n minus 3 to the 5th plus 2 plus 2. Now, here's the thing. From here, you can already say that the answer is no. Because in order to get the 5th root here to cancel with the 5th root here, I would need to take this to the 5th power, add 2, multiply by 2, and that's not going to cancel itself out to get to n. All right, so the answer is already no. 23. Okay, let's save 23 for later because, actually, you know what? 23 through 26, don't worry about those because I'm now looking at them and those problems are really, really nasty. So just, we will find some problems out of the book that are a lot easier to deal with. 31. Okay, find the inverse of each function. Okay. Let's see here. To find the inverse of each function here, I'm going to go ahead and substitute g of x with y. So from here, to find the inverse of a function, I'm going to switch x and y. So it's x equals -2, y plus 3 to the 5th. And now I'm going to go ahead and solve for y. So this is divide by -2. So that's going to be, move this thing up here, negative x over 2 equals y plus 3 to the 5th. Now I'm going to take the 5th root of both sides. So what I get here is the 5th root of -x over the 5th root of 2 equals y plus 3. And I'm going to subtract 3 from both sides. And what I get, sorry, let me pause this for a second or cut this out because I'm running out of space here. So I get 5th root of -x over 5th root of 2 minus 3 equals y. Now, your answer key is going to get something a little different because they go through rationalizing the denominator. I'm actually okay with this. I don't know. That's kind of fun. Okay. Number 31. Oh, we just did that. Did I skip anything? No? Okay. All right. Keep working. With this problem here, number 52, we're being asked to add, or rather subtract two fractions from each other, so we need a common denominator here. Common denominator, please don't think that hard. It is k plus 6 times k minus 2. K minus 2. All right, so here the right side is missing a k plus 6. The left is missing a k minus 2. So now what I'm going to do is I'm going to distribute this in. I get 6k squared minus 12k. I'm going to go ahead and distribute in a negative 4k, so I get negative 4k squared minus 24k all over my common denominator, which is k plus 6 and k minus 2. So now I'm going to go ahead and add these two things together. I get 2k squared minus 36k all over k plus 6 times k minus 2. Now I'm going to go ahead and try and factor this out just to see what happens. If I factor out a 2k, I end up with k minus 18. Okay, that doesn't help me at all, so just keep that. All right, your answer key might have factored out the top, but don't worry about that. It doesn't help you. All right, number 53 is a complex fraction. It is 1/3 over plus x plus 5 over 3. Oh, that's pretty cool. Over x plus 5 over 3. Okay, so now let's go and just simplify the top. Ordinarily, I would have to find a common denominator, except this time the denominators are already common. So I can just go and combine like terms. This is x plus 6 over 3 over x plus 5 over 3. The bottom x plus 5 over 3 will flip to the top, and it'll become 3 over x plus 5. The 3's are going to cancel each other out, and you end up with x plus 6 over x plus 5. Let's backtrack to number 40. Does anyone have a question about that problem? No? Thought it was relatively simple. Let's backtrack and look at number 40. So I've got m to the third, m squared minus 13m plus 30 over 7m divided by m squared minus 13m plus 30 over 10m to the third plus 30m squared. Okay, when we divide two rational expressions, we have to flip the second one. So I'm going to flip the second one. That is 10m to the third plus 30m squared over m squared minus 13m plus 30. And up top here, I've got an m squared minus 13m plus 30 over 7m. Right off the bat, those can go away. I don't even have to factor them. Notice how they're exactly the same thing. So from here, I'm going to go and factor the right top. So I can factor out, looks like a 10m. I'll have m squared. Oh, so not m squared. Sorry, because I factor out a 10m squared. Looks like I'll have an m plus 3 over 1 times 1 over 7m. The m's are going to go away. I've got an m up top. So I should have a total of 10m times m plus 3 over 7. Questions on that problem? Okay, cool.